Welcome everyone to my presentation. Today we are going to talk about the formation of Niagara Falls. The formation of Niagara Falls is a geological event that took place over thousands of years. So there are no eyewitness accounts or personal experience to share. However, I can provide a brief overview of the formation and history of the falls. The Niagara Falls is located on the border of Ontario, Canada and New York, USA. The falls were formed around 10,000 years ago, at the end of the last ice age. As the glaciers receded, they left behind a large amount of meltwater, which from the Great Lakes. The water from this lake drained through the Niagara River, carving out a path and eventually leading to the formation of the fall. The fall have moved approximately 7 miles upstream due to erosion since their formation. The rate of this erosion has been estimated at 1 foot per year. However, human intervention in the 20th century has reduced this rate of erosion significantly. Let's talk about the tectonic setting of Niagara Falls. Niagara Falls is located in the northeastern part of North America, straddling the border between Ontario, Canada, and New York, USA. It's situated within the interior of the North American plate, far from plate boundaries, any plate boundaries. The nearest plate boundaries to Niagara Falls is the Mid-Atlantic Ridge, which is divergent boundary located in the middle of the Atlantic Ocean. At this type of boundary, two tectonic plates are moving away from each other, and new crust is being formed from upwelling magma. The forces present at this boundary are tensional forces, which pull the plate apart. Normal fault where hanging wall block move down relative to the footwall block are most common at divergent boundaries. The rate of relative plate motion at the mid-Atlantic ridge is approximately 2.5 cm per year. This is relatively slow in terms of tectonic plate moment. As per the local and regional tectonic setting, the Niagara Falls region is relatively stable with few major faults and no significant seismic activity. The region is part of the stable interior of the North American plate known as the North American Craton. This area has not experienced significant tectonic activity for, for over a billion years. Let's talk about a geologic setting of Niagara Falls. Niagara Falls is located on the Niagara River, which connect Lake Erie and Lake Ontario. The falls themselves are a significant landform, and the Niagara Escarpment, a long cliff or steep slope, in another major landform in the area. There are no major mountain range, volcanoes, and oceans in the immediate vicinity. The Niagara Falls and the Niagara River were formed by glaciation around 10,000 years ago. The Wisconsin glaciation retreated, carving out the Great Lakes and the Niagara River. The water from Lake Erie flowed into the Niagara River and over the fall into Lake Ontario. The main rock type in the area are sedimentary, specifically dolomite and shale. The upper layer of the fall is hard dolomite, while the bottom layer is softer shale. The dolomite was formed from ancient seabeds, while the shale was formed from mud deposits. Over time, the water flow erodes the softer shale more quickly than the dolomite, causing the fall to slowly move upstream. In terms of geologic hazard, the area doesn't have a significant history of earthquake, landslides, flood, or eruptions. The main geological hazard is erosion of the fall. The fall erodes at an average rate of 1 foot per year, but measures have been taken to slow this rate. For example, water flow is reduced at night and during the off-season to slow erosion. The rockfall of 1954 is a notable event when large section of the fall collapsed due to erosion, significantly changed its appearance. Let's talk about the geologic hazard of Niagara Falls. The formation of the Niagara Falls is a result of a series of geological events. Number one, formation of Great Lakes. The Great Lakes were formed about 10,000 years ago at the end of the last ice age. As the glaciers retreated, they left behind large amount of meltwater which filled up the basin they had craved, forming the Great Lakes. Number two, erosion of Niagara Escarpment. The Niagara River, which connects the Lake Erie to Lake Ontario, flow over a cliff known as the Niagara Escarpment. This cliff is made of a layer of hard, pristine dolomite limestone on top of softer, more easily eroded shale. Over the time, the river eroded the softer shale and creating a waterfall. Number three, recession of the fall. As the waterfall eroded the underlying shale, large chunk of the overlying limestone would collapse, causing the waterfall to slowly move or reduce upstream. This process of erosion and the recession has been ongoing for thousands of years, creating the current location and appearance of Niagara Falls. Number four is human intervention. In the 20th century, human activities such as water diversion for hydroelectric power have significantly slowed the rate of erosion and recession. So, the formation of the Niagara Falls is a result of both natural geological process like glacial calving, differential erosion and recession, and human intervention. Niagara Falls is a classic example of a geological feature known as a waterfall. Geologists have learned a lot about erosion and the formation of waterfall from studying Niagara Falls. The falls have been eroding backward upstream since they are formed. The rate of erosion has been estimated at 1 foot per year. This erosion is caused by the force of water and the action of the water on the underlying rock. The rock at the top of the fall are hard, but the rock underneath are softer and eroded more easily. This caused the overlying rock to collapse, which resulted the fall moving backward. The community around Niagara Falls has been adopt has had to adapt to the constant erosion and movement of the falls. Safety measures have been put in place to prevent accident, such as railing warning signs. In addition, efforts have been made to slow the rate of erosion, such as diverting some of water for hydroelectric power. There have been no major hazard at Niagara Falls since its formation. However, the constant erosion and the movement of the fall pose a potential risk. The community and business continue to monitor the situation and adapt as necessary. Studying Niagara Falls helps geologists under the process of erosion and waterfall formation. It also provides valuable lessons to communities and business to adapt to about adapting to a changing landscape. That's all I have for now for the presentation. Thank you so much for watching.